The trend for all the world seems to be the immersion of viewers into whatever content is being communicated. Our super session today, Display Technologies of the Future, will discuss some of the very latest concepts and evolving technologies being used to bring viewers into the future, creating what we might call windows into other worlds. Leading our super session is Peter Putman. Peter is president of Rome Consulting, a company that provides a variety of services in the area of displays, display interfaces, and related products. Pete is a regular contributor to industry publications such as Sound and Communications and TV Technology. He publishes hdtvexpert.com, a web blog focused on digital TV, HD TV, and display technologies. Peter is a senior academy instructor for the International Communications Industries Association. Please join me in welcoming Peter Putman and our executive panel.
Good morning. A little surprise this morning with the weather, huh? You know, I was stuck over behind Hooters at the Desert Rose, and I ran over to Hooters to try to cross the street to catch the monorail, and I waited as long as I could. It was pouring rain, waited and waited, waited. Finally, ran out of time, had to make a break for it, and, you know, by the time I got here, I got soaked, and that was just the cab fare. Okay, yeah, but I'm here all week. Tip your waiters. I'd like to thank everybody for coming out this morning. We have a very interesting session planned for you. We're going to look at the larger scope of display technology, talk about some interesting applications that go all the way from devices you hold in your hand all the way up to digital cinema, and try to give you a little bit of a snapshot as to where the world of displays is headed. Normally, I would ask everybody who is in one of these sessions to please turn off your smartphones and put them away. However, I'm going to flout that by using my own smartphone to actually do a presentation. This is a Droid Razr Max, and this goes very nicely with what we're going to talk about, and that is that because of these displays and their resolution and their ubiquity, I literally could do an entire presentation off my phone using a micro HDMI connection. So if you'll please bring my slides up on the screen, we'll get started. Anybody recognize, whoops, I think you have an old frame buffered there. Is that possible? Now, again, this is something running off a phone, so I have to warn you that, yeah, you're not actually. I think you've captured a still frame from before, because there we go. Nope, they've got a still frame locked in there. What we're going to do today is we will have several panelists. If you'd like, you can just bring my regular slides up on the screen. Why don't you cue those up? For some reason, we have I didn't promise you it would actually work, but, oh, there it is. There it is. Let's try it again. And let's see if this actually animates. Nope. Oh, that's the computer. Okay. Very good. So, let's get started. I would like to run it off the phone. It ran before, but you know the old axiom about something that tests 100% reliable in the laboratory and fails the minute you take it out into the field. So, future display technology. Here's our list of panelists that we have this morning. We have Gary Mandle from Sony Electronics, who's going to talk to us about organic light-emitting diodes. I'm sure you've heard about them. They were all the rage at CES this year. Super thin, flexible, high brightness, high color saturation displays. From IMAX Corporation, we have Robert Lister, who's going to talk about where is cinema going. Cinema has all gone digital now. Is there another step to it? Where can we go with larger pictures, more immersive environments, more immersive sound fields? Walt Husak is here from Dolby Labs, and he's going to tell us about what's going on with 3D. Now, you all remember 3D. 3D was a big splash a few years ago at CES. We saw a lot of it here at NAB. Then it kind of faded into the background. But it's not dead. And he's going to talk specifically about auto stereo 3D, glassless 3D. Sean McCarthy here is from Motorola Mobility. He's going to address the question that a lot of you probably have with the move to 4K and new media delivery methods. How do we get this stuff into the home? What's happening with codecs and compression? How do we move signals around so we can take advantage of these new displays? And finally, we have Simon Parnall from Cisco, who's going to talk about virtual screen environments. Literally create your own screen, large screens that you can interact with. You can do gesture control, and you can have second screens linked to them, such as tablets. To give you an idea how big this display industry is, let's take a look at the market. Now, I have to apologize, so you'll notice that in my slides it says XXX. Display Search, NPD Display Search, which is probably one of the premier analyst firms in the world, was supposed to give me numbers on how big the display business is and what the value of it is. I was assured a week ago I'd have these numbers. I never heard from them, so I'm just going to make it up. No, seriously. We would estimate there's probably been over 1 billion displays manufactured and shipped fiscal year 2012. And that includes everything from phones and small displays that go into cars all the way up to large TVs. And the handheld display market, which is tablets and phones, and how many of you have a tablet? Put your hands up. Yep, see? That is the fastest growing market right now. Handheld displays right now probably account for between 15 and 20% of all displays showed, and that number is growing very, very rapidly. Traditionally one of the largest markets is televisions. However, televisions, a market that's in decline right now. Although over 233 million of them were shipped last year, that's down from the year before. So I'm going to give you some summaries here. And I mentioned TVs. Annual LCD TV shipments declined for the first time in 2012 by 1%, not much. It's the first time it's ever happened. Okay. Total global shipments fell over 6%. North America was essentially flat, but the biggest dips were in Japan and Western Europe, 68% and 58% and 15%. The largest market in the world is China, the largest consumer market in the world. It is now the largest market for TVs. So demand raised 6% to nearly 52 million. And that's the first time any region has gone over 50 million. So what are people buying? Well, last year, 203 million were LCD TV. Plasma, 13 million. OLED, 0, because it's too small a market to track. CRT TVs are not dead yet. They're still out there, 16 million. Rear projection TVs, about 50,000. That market's pretty well dead, for a total of 232 million. Now, here's the market share. Literally 9 out of every 10 televisions sold last year were LCD. How many of you have an LCD TV? How many of you have more than one LCD TV at home? Okay. Plasma, 5.7% market share. How many of you have a plasma TV at home? Well, there you go. You're backing the numbers up. Believe it or not, there were more CRT TVs shipped last year than plasma TVs. Hard to believe, 6.9% versus 5.7%. And in fact, many of the plasma TV manufacturers are now shuttering plants, closing down, and the consensus among analysts is pretty much that plasma TV will be gone within a couple of years. And there's the year-to-year growth. Now, again, across the board, down for everybody. So for LCD TV, down 1%, plasma down 23%, CRTs down 38%, rear projection down 59%. And the last manufacturer of rear projection TVs bailed out of the market this year. That was Mitsubishi, so it's officially a dead category. Now, glass. Who here remembers the movie The Graduate? And that famous line, I got one word for you, plastics. He was wrong. I got one word for you. It's glass. Touch-enabled mobile devices such as smartphones and tablet PCs will drive worldwide cover glass. That's a thing on your phone that you're always breaking when you drop it, to more than 1.5 billion in 2013. So think about that. Just handheld devices alone, 1.5 billion pieces of cover glass in 2017, more than 2.5 billion by 2017. Shipments forecast to reach more than 2 billion by 2017. Tablet PCs are only 14% of that market, but they're going to grow like crazy, reaching 200 million in 2013 and 400 million by 2017. Touch penetration is basically 100% in tablet PCs, and they have larger screen sizes than smartphones. How about another market? Tablets. Okay? 240 million units are going to be shipped this year. And the takeaway here is that will be more than the PC market. That has never happened before. Tablet PCs with 7 to 8 inch screen sizes are going to be 45% of the market. How many of you have an Apple iPad? Okay, how many of you have another tablet like a Nook or an Android? The trend here is larger screens. Now, the largest one I've seen so far is the 20-inch 4K Panasonic, which I'm sure they have in their booth, and it's rather large. 20 inches is not exactly something you can carry around easily. Humorous anecdote, Steve Marr from Panasonic took that to a trade show in California, and he said when TSA asked what it was, he went, "Shh, that's the iPad 6. Don't tell anybody." So North America is going to be the largest market, 35% market share, 85 million units, but China will be right behind with 65 million units. How about automotive? You don't realize it, but there's a lot of LCD glass in your cars. Shipments of thin film transistor LCD displays used in cars, primarily for things like navigation and rear seat DVD players, 49 million in 2012, and it's going to increase to 70 million by 2016. So everybody wants displays in their car. They integrate convenience, safety, and functionality. And one of the things driving it, not surprisingly, is hybrid automobiles. How many of you drive a hybrid? Okay, it's a small amount, but your hybrid display can show you how much fuel you're using, whether the drivetrain's working correctly, whether the electric power is being regenerated. All that's happening through LCD screens. It may change. We may hear from Gary that OLEDs may replace them because OLEDs can do one thing LCDs can't do. They can bend. They can flex when they're under vibration. And Japan, who's struggling to sell glass for products, dominates this market. They may not be doing well with TVs, but they are way at the head of the class when it comes to small LCDs for automobile functions. And 4K. How many think 4K is a fad? Ooh, no one? Did I see a little hand go up there? How many of you think 4K is for real? It's a real thing. It's a next step. Okay. Well, here's some perspective. And PD Display Search, in their quarterly large area TFT panel shipment report, they say that by 2013, the end of the year, 2.6 million 4K by 2K LCD panels will be shipped, up from 63,000 last year. So it went from 63,000 to 2.6 million. Innolux in Taiwan is being very aggressive with this. They have a full line of panels, 39 to 85 inches. At CES this year, Westinghouse Digital showed a 50-inch, which they say will sell for $2,500, a 55-inch, which will sell for $2,900, and a 65-inch, which will sell for $4,000. But primarily, the display manufacturers will focus on 50-inch, 55, 58, 65-inch sizes. Those are expected to have the highest volume. So really what I wanted to do there is kind of set the table for you, just give you an idea of what's happening in the display market, where the interest is. Obviously, tablets are a big thing, and also phablets, large phones, 5 inches and larger, that almost resemble a tablet. So why don't we get started, and we will call our first presenter up to the podium, and that will be Gary Mandle from Sony Electronics. And let me tell you a little bit about Gary. He's a very interesting fellow. He's been with Sony from as long as I can remember. He's a senior product manager. He's worked with all the cool stuff when it's come out. The first LCD reference monitors, now the OLED monitors, the SXRD projectors. His current focus is on the OLED technologies, which are used for video and film production and post-production applications. And other areas of work that he's participated in, image stabilization for cameras and CCD sensor development, and he has patents in these areas. So please welcome Gary Mandle from Sony Electronics.
I'd like to thank NAB. I'd also like to thank Peter for inviting me here, and we can talk about some of the things going on in OLED and what we're going to start seeing in the future. So I think we could get started. We'll talk about the state of the art. This is something that's been coming for a long time. In Sony's case, we actually started development of this in 1994. So this hasn't been such an easy task. But now that we've gotten to the point of making products with these things, we're seeing some real benefits, and I think everybody is going to see a really interesting future in displays as this moves on. One of the things I want to talk about quickly is what OLED is. There's plasma, which uses a plasma gas, LCD using a backlight system, and a transmissive LCD panel. OLED is quite a bit different. One advantage of OLED is it's a self-emissive system. The way it operates is we have a set of layers using organic compounds, basically benzene-based types of materials. Within these materials, we can transfer charges over certain orbitals in the molecules. We have a set of molecules called host molecules, and then we have another set called guest molecules. What happens is we put a charge in on each side. If you look at these, the way the electron orbitals work is as they come down through these host molecule layers, they cannot transfer. You cannot combine these. So from the positive areas, we have the holes coming up to the center area, and from the top areas, we have the electrons coming down, and they meet in the center. What happens is we have a thing called recombination. where the materials meet into an emission layer which houses the guest molecules. Since you cannot make this transfer within the host molecule, it moves over into the guest molecule, and the guest molecule will allow this to happen. However, when the guest molecule lets the hole be filled by the electron, it becomes unstable, and it needs to come back to its ground state. And the only way it can do that is to emit a photon, and that's how we get light out of it. So this is a really interesting new technology, basically building its own light, and something you can control in an array, and as of now, into some very dense arrays. Now, Sony's very proud. We've been working on this a long time, and I think in the professional film and video business, we're known for delivering OLEDs, being almost the only ones doing that. However, we are far from the only ones. This is a list of a lot of the other companies that are working on the technology. As Peter was talking about, OLED isn't just going to be a display for viewing images for television. It also can be used in a wide range of different areas, all the way from automotive, as he talked about, but even lighting and some other areas. It has some very distinct advantages. These are some examples. This is a Samsung Galaxy 3 using Samsung's 3-inch OLED. Then Samsung also has introduced or has shown a 55-inch OLED TV, HD resolution, and below is the LG. And these have been the talk of on the consumer side of things, of what's coming down the pike. On our side, we're now going into the third generation OLED panels. We're introducing a new lineup this year, and we've had quite just great success in the professional markets. As of this month, we've delivered well over 20,000 units, and this is now becoming pretty well accepted as a good CRT standard, and is now becoming a new reference in video production. This CES, we came out with a 56-inch OLED, but we threw it in as a 3840 panel. So we're showing this. We also have this in the booth this year. It's a 56-inch. This is in cooperation with Taiwanese company AU Optronics. It's our technology, and it's our panel, and we're working with them on the manufacturing. But this is the highest resolution and the largest OLED right now that can do 4K. And one other note, something we haven't been talking about, we also have a 30-inch version, which is now going to be coming out as a professional BVM grade or evaluation grade type of monitor, and we also have that in the booth this year. All right, thank you.
All right, thanks, Gary. Our next speaker is concentrating on screens a little bit larger than a 30-inch OLED, and that is Rob Lister from IMAX. He's the Chief Legal Officer and Chief Business Development Officer. He joined the company in May '99 as Senior Vice President, Legal Affairs and General Counsel, and he became Senior Executive Vice President and General Counsel in 2007. Prior to joining the company, he was Vice President, General Counsel of Clearview Cinemas, and he also served as Associate General Counsel of Merit Behavioral Care Corporation, a behavioral health care company. He's a member of the Board of Directors of 3Net. 3Net is a joint venture of Sony, Discovery Communications, and IMAX to provide 3D content for the home. Please welcome Rob Lister.
Thanks, Peter. I actually had a slide presentation, but it was all about host molecules and guest molecules, and you stole my thunder on that, so I'm not going to use that. No, thanks to Peter, thanks to NAB for inviting IMAX along. We like to think of ourselves at kind of the intersection of entertainment and technology, so I think we share that perspective with you folks. And the other thing that we share to a great extent with a lot of the people in this room, a lot of the people on this panel, is a thirst for innovation. And if you look back at the history of IMAX over the last 5 to 10 years, this company was literally revolutionized by innovation, completely turned around by innovation and developments in technology. If you go back to 2002, 2003, there were about 200 IMAX theaters in the world. These were generally standalone theaters in science centers, museums, or aquariums, and they ran nature and science-related movies, generally 45 to 60-minute movies with analog film prints that cost anywhere between $30,000 and $50,000 or $60,000 a film print. And it was very much a broken model. It was impossible to amortize those film prints across a broad network. It would cost upwards of $15 million to build a bricks-and-mortar standalone IMAX theater. And there was an enormous chicken and egg problem that the company had from a content standpoint. We weren't able to get enough film product into the system to justify an expansion of the network, and theaters in the network didn't have enough films to play, to justify doubling down on their investments. So we were stuck, in a very difficult place, in a very difficult environment. Our stock hit a low of 51 cents in December of 2001. And there was no choice but to invest in the thing that the company knew, the thing that the company had been built upon, which was innovation. So in 2002, we developed a digital remastering system that allowed us to convert Hollywood content into IMAX's format. In 2006, we developed a digital projection system that replaced the analog film-based system, eliminated those incredibly expensive costs of film prints, and just as significantly, we designed the digital system so that instead of being built into a standalone IMAX theater, it could be retrofitted into a multiplex. And the results of those innovations, that series of innovations, is that we went from a network of 200 screens in 2002 to 750 screens now in 53 countries. IMAX's Hollywood box office in 2002 was $8.1 million. In 2012, that number was $621 million. And our brand recognition in the developed countries around the world exceeds 75%. So all of obviously the theme here is that all of that was made possible by innovation, the digital revolution, and doubling down on the thing that the company knew, which was to create an immersive environment, the most immersive display that one can experience, and yet do so in an efficient way, in a convenient way, in a cost-effective way, and therefore bring the IMAX experience to more people, and we've been successful doing that. But the IMAX proposition has always been based upon the notion of differentiation, being able to have a completely different experience. We call it being inside the movie in an IMAX theater versus a conventional theater versus a home theater, versus an experience with a mobile device. And to maintain that differentiation, innovation must continue. It can't just stop. We can't say, boy, we turned things around with some digital innovations over the last 10 years. It has to have a prospective, a going forward, a proactive approach. So we're now undertaking the largest investment in terms of capital, in terms of human resources, in terms of intellectual property investment in our company's 46-year history. And we are developing the next generation of projection system. It's a laser-based projection system built based upon intellectual property we acquired from the Eastman Kodak company. It's going to, in our view at least, our humble opinion, it's going to revolutionize the way people experience movies. It's going to have contrast and levels that exceed 8,000 or 9,000 to 1, luminosity 3 or 4 times the luminosity you're seeing now, a clearer, more distinct, sharper image than even IMAX old 1570 film was able to provide. And we're not just retrofitting laser engines where xenon engines were before. We're building a ground-up next-generation projector that's going to have image enhancement tools, audio enhancement tools, and in our view, at least, and this is something I think we'll talk about, that's the way our innovation translates into creating more immersive experiences for consumers and more differentiated experiences that they could find elsewhere. So I look forward to discussing that with you, and thanks for having me.
Okay, thanks, Rob. Quick question. How many of you out there have a 3D television? Own a 3D television? How many of you actually watch 3D on your 3D television? That hand never went down. Not very many hands went up. This is one of the problems with 3D. And how many of you think 3D is a fad that comes around every sunspot cycle and then disappears again? Now, there's a few hands. Well, one of the problems with 3D, and by the way, the market corroborates what you're saying. 3D TV's been a difficult sell to people. You will hear people that will say that, well, 3D TV sales are increasing. Part of the reason for that is 3D is being built into more and more televisions, and it's just included in the purchase price. It's not really a premium. But one of the things that I've identified as a bit of a problem with 3D when it got out of the gate is you had three camps. You had one camp saying glasses with batteries in them, active shutter, full frame refresh, 120 hertz. You had a second camp saying passive film retarders built into the glass and cheaper passive glasses. Two systems are incompatible, both valid ways to watch 3D. And a third camp that says, you know, the goal really ought to be no glasses at all. And I think this is really where the future of 3D lies, that you don't have to put the glasses on to watch it. And that technique is really known as auto stereo. So basically what happens is, depending on where you're sitting, your eye can see a left eye view and a right eye view. The problem with auto stereo for a long time is that every time you divide and create more views in the screen, you chop up the resolution. Perhaps 4K is a way to get around that problem and make it a more viable product. So our next speaker is Walt Husak from Dolby. Dolby has a very cool auto stereo 3D display, which you can see in their booth. He's the director of image technology. He began his television career at Advanced Television Test Center, and he has joined Dolby in 2000, spent his early years studying and reporting on advanced compression systems, digital television and Blu-ray, digital cinema, executed and managed visual quality tests, is now a member of the Chief Technology Officer's Office, focusing his efforts on 3D for digital cinema and digital television. He's authored numerous articles and papers, an active member of SMPTE, MPEG, JPEG. Is there any other PEGs I missed? ITUR and SPIE, and chairs the SMPTE Frame Packing Ad Hoc Group. That's frame packing for 3D, not something else. And the MPEG Frame Compatible Ad Hoc Group. Please welcome Walt Husak from Dolby Laboratories.
Thank you, Peter. Thank you, NAB. The first thing I want to talk about is what works and what doesn't work for 3D. And it's pretty clear in the theatrical market that 3D works fairly well. People are flocking to the theaters, seeing movies, paying an upcharge for it, so it works fairly well. And as Peter pointed out, 3D sales are going up. However, the attach rate on the glasses is fairly low. And the manufacturers themselves are fairly disappointed with their margins, but they would like to get a better ROI on their sunk costs. Consumers themselves like 3D. After all, they are going to the theaters and stuff. But at home, they're not. And the interesting part of that is, 3D at home is largely, and even in the theaters, is largely an event-driven experience, but it seems as if at home people aren't very interested in the events unless it's a large award show, a large sporting game, or a movie. On the broadcast side, they're suffering from the same sort of problems where, if you look at the broadcast going to the home, there's some uptake on it, but not a lot. But yet, as they go into the pubs, there is a big uptake to it. And this leads us to sort of a chicken and egg issue, that there's a limited revenue potential, and therefore there's a limited draw for more content. So that presents a real problem. So what did we learn on this? Glasses in the theater, works great. Glasses in the home, no. So if you take a look at how we watch TV, this is sort of the traditional way, the way I grew up watching TV. Family, largely event-driven. And you sit down, you had 3 networks at the time. Now you're inundated with 1,000 channels. It's a whole different story. Furthermore, nowadays, you're not usually watching with one screen, you're watching with multiple screens. And so having a set of glasses and looking at different screens doesn't work very well. So in order for 3D to be successful, we have to move away from the event-driven paradigm. It's got to be considered a feature, but not necessarily the main feature. And it also cannot rely on external devices such as glasses. Plus, it must allow simultaneous viewing with multiple screens, and it must support alternative devices. So the perfect storm's kind of happening here with auto stereo. You have 3D TV, it's out there, it's penetrated, people understand it, there's some content being made. Now you've got these ultra-high pixel density displays coming out on the TV side, the UHD TV, and on the tablet side, the Retina displays and their equivalents of other manufacturers. And that makes it so that glasses-free TV really has, its time it's come. So if you kind of look at how you have to think about this, there's a couple different traditional delivery paths that you have to deal with. You've got the HDMI link, you've got the typical fixed media devices, you've got the tethered devices, and then you also have the gaming devices. All of these can feasibly feed into auto stereo and enable auto stereo. But the other thing you have to think about is the new over-the-top sort of delivery systems. And these systems actually are penetrating into a wide variety of devices, including the traditional devices such as Blu-ray players and fixed devices, TVs themselves, but they're also going straight into laptops, computers, tablets, and phones. So you have to look at delivery to all those devices in order to enable the entire ecosystem. In the traditional delivery system, at the end of the day, the key criteria is you cannot disenfranchise existing stereoscopic owners. And that kind of leads you down one path for a solution. And in this way, you want to send a frame-compatible signal in, because that's, after all, the way that's pretty much deployed now for physical and legacy reasons. But you also want to send an enhancement layer, some way of sharpening up the image, and then some view metadata to create the multiple views that are necessary for auto stereo. In the new delivery systems, the key thing here is bandwidth limitations, and so you have to look at the way how to overcome the bandwidth limitations for this. In this particular case, you kind of want to send a 2D view or a fixed view for those that have a 2D device, and then send the view metadata for the 3D device. And this can create an ecosystem, and this ecosystem will then drive the auto stereo. So the takeaways here basically are, you get the new high pixel density displays can do double duty as a display itself, plus be able to enable auto stereo. And existing systems already exist that can allow you to deliver the content to the home or to the portable device. So if you take a look at the view metadata system, there's several different ways of coming up with those. And in theatrical releases, most of the depth and placement data is already there due to compositing, animations, things like that. But on the other hand, you also have the high-value, real-time content that works extremely well and is a big draw: sporting events, awards show, dancing shows. And here you need to have an automatic system, but it has to be a high-value automatic system. But likewise, once the auto stereo becomes ubiquitous, as we move away from an event-driven into a more 2D-driven thing, you're going to have, the niche casting channels, the syndicated shows, library content, all of that can be converted and done in 3D. And then finally, you can always do inset metadata generation. All of these things can drive auto stereo and make it so that stereo gets another revival. So thank you for your time.
One of the challenges we face as we make displays bigger and increase the pixel count and increase the color bit depth and everything else is that the data rate, the amount of data we're pushing through a pipe, increases by an enormous value. So for a 4K TV running 3840 by 2160 resolution, that's 4 times the data rate we would use for 1080p. The problem is, as usually the case, our highways aren't fast enough or wide enough or don't have smooth enough roads. So we have to pay attention when we talk about enhancements and displays to the highways, the pipes, bandwidth, compression. How do we get these signals into their home? And this is one of the topics our next speaker is going to talk about, Dr. Sean McCarthy. He's a technical fellow at Motorola Mobility, which, if I understand correctly, is now part of Google, correct?
Google right now.
Yeah, it's part of Google right now. So if you have a Droid phone, that's basically Google. He leads advancements in state-of-the-art video processing, compression, and practical vision science. He's authored several papers on retinal processing. He has various patents on image and signal processing and resides on the board of the MPEG Industry Forum. He earned a Bachelor of Science in Physics from Rensselaer Poly. He's an RPI guy, all right. And earned his doctorate in bioengineering jointly at University of California, Berkeley, University of California, San Francisco. Please welcome Dr. Sean McCarthy.
Thank you, Peter. Thank you, NAB. I really appreciate being here this morning. This morning, I actually want to talk about all these fellows really driving our business. It's not wrong to say that new generations of displays, new generations of codecs are really driving what we have to do in Motorola. And my job in Motorola is really to drive video quality, to drive compression efficiency, and all the encoders and transcoders that are used in the pipeline to deliver quality content to the home, to the living room, to smartphones, to tablets. Okay? And the big questions for us now, with all these new displays emerging and all these new technology options, is how are people watching television? New displays are actually driving different behaviors now. And as Peter mentioned, what do we have to do in terms of bandwidth? How do we make sure we deliver really great consumer experiences to the home and the tablet, wherever people are watching? And there's two parts of this. It's a little bit of an odd kind of presentation, because first I want to share with you some market intelligence from a report and a study that Motorola commissioned, a global study. And the other is to look a little bit about applied vision science. And Simon and I were talking earlier before the show that applied vision science is actually becoming much more important as we look at display technologies and how people consume content. As Peter mentioned, my background's actually in bioengineering. I spent many years doing electrophysiology and applied signal processing, understanding how the retina and the visual system try to work as a signal processing device. So this fourth annual Motorola Media Engagement Barometer is the fourth time that Motorola has commissioned a study in 17 countries, 9,500 consumers, to really get a handle on what people are actually doing rather than speculating. And I want to share the first result there is that the living room is still the epicenter. That's the place where people still come together and they watch broadcast television, they watch IPTV, cable, satellite TV. But if you look at some of the numbers here, you're seeing that consumption of content on smartphones and tablets is gaining ground rapidly on the traditional television experience, even in the living room. Right now, 29% of weekly content is recorded, but a third of that is never watched, which I think is an interesting fact, because that's bandwidth we're spending for content that's not being seen. When we look at other rooms in the house, we find that, in fact, smartphones and tablets are driving the behavior there. More people watch entertainment content and broadcast TV on their tablets and smartphones, or smartphones and tablets, than on TVs in the bedroom. Significantly more, and that number is growing very quickly. And 10% of tablets are used in the kitchen. So if you're in the kitchen, that can now actually be a legitimate way for you to consume content. When you're on the road, we found that more than half of the people in the study, of 9,500 people, have downloaded TV programs to a device. And right now, most of that content is still being seen on laptops and PCs, but a growing number is being seen on smartphones and tablets. Every day, 27% of consumers globally download content to watch away from home. And the TV services are watched away from home 4 days a week on average. So clearly, there's a big difference in the way people are consuming content. And so the challenge comes back to us. How do we make sure that that experience is seamless? How does that experience really satisfy consumer expectations? So I want to back up and talk about visual acuity. Apple, very rightly so, has made a big deal about retina displays. And the idea behind retina displays is really the same as the idea behind HD TVs in the home. The pixels cannot be discriminated when you're looking at a regular, a normal viewing distance. Basically, you're at a level of acuity that's called simple acuity, or pixel fusion distance, if you like it, in the industry. But people actually have different levels of acuity. 150 years ago, Herman Snellen defined the concept of 20/20 vision, and he did so by engineering letters. These are actually called optotypes, and this is the typical eye chart that you're familiar with. And he designed them so that at certain distances and certain lines, the little gap in the E, or the gap in the F, or the gap in the P corresponded to 1 minute of visual field. So there's 180 degrees side to side. There's in 1 degree, there's 60 minutes. And 1 minute of visual field was defined as 20/20, as the ability to actually read and discriminate shapes. Okay? On the other side, almost 100 years later, Gerald Westheimer coined the term hyperacuity to point out that vision isn't limited by the Nyquist limit, the rate at which data can come into the system, but by the brain's interpretation of visual features. And you can actually discriminate, for example, in a vernier task, an offset of 2 line segments that is much smaller than the size of a photoreceptor. So when you look at this mapped into evolution of TV, I think something interesting happens. Old standard definition TV, we were at the level of legibility. This TV could not support any finer resolution capability of ourselves than reading. When we moved to HD TV, we went through this 32 degrees or 30-degree field of view, we jumped into the world of simple acuity. And this was a big jump. And now going from simple acuity to 4K in these smaller HD 4K displays that we're seeing coming out now more economically, we've jumped into the world of hyperacuity. What's interesting is in the mobile devices, we actually jumped right to that. Right? If you have a QHD or a 1080p smartphone or tablet, you're in the world of HD. But the tablets and the laptops and smartphones are actually already into this world of hyperacuity. So 4K in the living room, I think, can be argued is actually trying to catch up to what we're getting to beyond HD already in smartphones and tablets. So what does this mean in terms of bandwidths? It means that I can deliver standard definition content on an HD TV, and I need the bandwidth I needed for standard definition. I can do that for tablets, but when I start getting to 4K and wider field of views, the model falls apart. Standard definition on a 4K, I've seen it, it's not pretty. But we can then start ramping up our bit rates to start supporting these new devices. So we can deliver HD bit rates for everything from HD to smartphones and tablets all the way up to ultra-high definition TV. And then we can turn the knob a little bit more gradually, and start stratifying that hyperacuity. So I think one of the take-home messages here is that although when we jumped from standard definition to high definition, we had to pay the bit rate budget all at once. Going from high definition to 4K is going to allow us to kind of ramp up our bit rates more gradually. When we look at that in terms of the existing coding technologies, AVC, which is H.264, if we use as a benchmark, say 1 normalization, so say that's 10 megabits or 5 megabits per second for HD, we would need 4 times as much to satisfy the full hyperacuity capabilities of a 4K display. But if we couple that with HEVC, which is high efficiency video coding, that's the new standard that was just announced earlier this year, we've seen that we actually have a range. We can actually deliver from half of what we're delivering today to twice as much as we deliver today to get this full range of basic HD quality all the way up to an enhanced level of viewing. So the summary here is that living room remains the epicenter, but the multi-screen home is now a reality. Smartphones and tablets are driving most of our behavior outside of the living room and on the road. Tablets could actually be our first beyond HD experience. And I won't call it a 4K experience, but it's beyond what we're normally used to in the home on HD. And the combination of HEVC with this jump past the simple acuity threshold means that we probably have a lot more flexibility in how we deliver bitrate to deliver really good consumer experiences. So that's what I have. Thank you very much.
Thanks, Sean. Many of you may be surprised that Netflix, and we have some Netflix subscriber here. Netflix, we got a lot of them. The minimum acceptable bit rate to get Netflix service is 550 kilobits a second. That's it, 550 kilobits a second. So we have real challenges there. Our last speaker, working in some really interesting areas. A television is a television. It could be 80 inches, could be 60 inches, could be 32 inches. It's basically a rectangular screen with a frame around it. Could be really thin, could have some things like 3D and all built into it. But what if a television becomes a wall? And what if it becomes something that takes up the entire room that you're in? And what if you can control it interactively? What if you can work with it with a second screen? So there really isn't a, per se, television hanging on the wall. Maybe the wall itself becomes a television. Well, Simon Parnall is working in that area. He's from Cisco, and he's leading a team dedicated to research and collaborative activities, acting in a thought leadership capacity in the areas of future television systems, novel approaches to integrated hybrid television design, and new thinking for the connected home. He joined NDS, which was recently acquired by Cisco after leaving BBC's Research and Development Department in 1999, and he worked there for 19 years. He was responsible for BBC system of presentation of widescreen mobile films and RDS, radio data system, research work on highly efficient traffic message delivery to mobile navigation systems. He was chairman of the DAVIC's Applications Technical Committee, and in this role he pioneered the concept of the PVR, and in 1999 founded the TV Anytime Forum, an organization that he chaired until 2005 when it completed its second phase of specifications, now available as an international standard through ETSI. Please welcome Simon Parnall from Cisco.
Well, thank you very much. I spoke about Fresco, that's our project, yesterday, so I'm going to just reiterate very quickly some of those slides. Very much, we're looking here at television that breaks out of the normal paradigm, television that actually we've seen many times on science fiction films. And I think if you look at this, you'll see, apart from the Comcast foyer on the bottom right-hand side, many of you may have seen that, you'll see films there that you've seen on TV that show how actually television can evolve and to actually occupy the space on our walls. This is our first room here. This is a 3.6 meter wide sort of panel, as it were. And we have 4 key axioms that we believe are going to be important in the future. Firstly, that television will become frameless. Every single bit of video will be shown at its correct size and shape. It'll be unobtrusive, meaning it will blend in. It'll be ultra high definition, and it'll be ambient. Just as an example of unobtrusiveness, I wanted to show you that, now you can tell this is England, by the way, because there's no sun in the sky. There is a seagull there on the left. But there are 2 examples here of solar panels. Now, which house would you prefer to have? The one where you just put these panels on the roof and they look really ugly. I mean, if you're a local planner, you wouldn't want that sort of thing. And then the one on the right-hand side, you see how those panels are blended in with the roof. I know which one I'd go for any day. So what drives the experience of this new world where television can inhabit the space? It's a synergy between broadcast, broadband, and what we call demotic content from within the home. It's metadata driven. The layout engine, which could exist in the cloud, controls the placement, the priority, and the relationships between the various images. The program-associated data effectively gives collective experiences for the whole family, and yet it allows you to have individual experiences. And what we do is we place images on the wall which cause you to look down and actually respond personally to those calls to action. So you can have both a collective experience and also an individual experience. So just finally, we also incorporate the concept of video chat in this world, where actually, rather than talking to the person directly in front, why not share the experience on the side? So this is another reason why we want this experience to be delivered onto the various walls of the home, because we want to be able to have both forward relationships and horizontal ones. I used the joke yesterday, but if you were watching a piece of video with your wife, you'd hardly want her to sit next to the TV so that you could look at her whilst you're watching the TV. It would be a short-lived relationship if that was the case. You want to sit alongside her to actually look at her and actually share the experience, and that's what we want to do with video as well. It's an extensible, it's a scalable architecture. We see this as being something that can persist around the home and beyond the home, linking all the various devices that you have. So we think of this display technology as being frameless, unobtrusive, ultra-high definition, and ambient. Automatic presentation that adapts to your preferences. And once again, using this word immersion, we think immersion is something that you will drive. You're either very interested in something or it's a peripheral interest. You want to be able to drive the size of the picture. Why should one size fit all with television? That's something that we've been forced to have up till now. Why should that be true in the future? Supporting a range of content types and resolution. Please come and see our demo, by the way, if you're able to, in room A1113 on the stand. So I'll leave it there. Thank you very much.
All right, thanks, Simon. Okay, what we're going to do now, you've gotten to know each of our panelists a little bit. They've given you some background in areas that they're working in. We have microphones set up in the room. and you are welcome to come up and ask questions. We will have some questions of our own up here to get things started. But if you'd like to ask a question, please come up to the microphone, and if you want to, you can state your name and affiliation or just your question clearly. I'd like to kick a few things off. Gary is, again, I asked him to speak because he's very deep into OLEDs. A lot of us have seen them. We know that they're very thin, and they're very bright, and they're very colorful. We don't know a lot about how they operate. And one question that I'd like to ask Gary, if you could very quickly just give me an idea of why we may not have as many OLED TVs, or what are the obstacles we're trying to overcome? What are the challenges that face OLEDs currently to make this a mass market substitution for, say, tablets and phones and television screens?
Well, in the beginning of this, OLED initially to develop it has taken quite a while, quite a bit longer than I think people really understood. It's kind of amazing, the actual grassroots of OLED even started before LCD was being worked on, and it's just taken that long to do.
You're talking about over 40 years ago.
Over 40 years ago, yeah. Initially we were looking at 1965 when the first people started understanding this process. We actually started our development in 1994, and it's taken till now to get this out. So that was the first thing. So you have this huge investment that's been built up over time in order to get this going. Now that we're there, we have the first initial products that are starting to come out of the market. But these products are being built on converted LCD fab lines. I won't say from the Sony side of things, but on our competitor side of things, they are still running into issues of yields and still getting them out, and that's taken quite a while. Once those are overcome, which I think is this year, I think you're going to see very rapid growth of these. And as more panels are being built and you see more people entering into the market, this is going to become much more of a mainstay. You see the prices come down, and it's going to be it's even been predicted that OLED will replace LCD after sometime around 2020 or so.
Has the biggest problem with OLED been differential aging of colors? By that I mean that when you have OLED colors, some of them wear out or fade faster at certain rates than other colors.
Yes, that was actually in the beginning. That was a very large problem. I don't know if anybody remembers. Sony came out with our first OLED, which was an 11-inch, the XEL1. And the blue phosphor in that OLED panel had a very short life. It took quite a bit of development. We went out on our own and developing some of our own materials in order to do it. But in our professional line now, we've overcome that problem, so much so that the life of those panels now exceeded the life that we had at the similar CRT models. So again, it's a progress and an investment, and everybody seems to be overcoming these initial problems.
All right, thanks. All right, we have a question over here.
Hi, Simon. Phil Lelyveld, USC Entertainment Technology Center. I love the concept of what you're showing. Can you talk a little bit about the sensors around the home? How are you gathering data? And are you building in protections that conform with European privacy laws?
So this is a question to me, yeah?
Yes.
Sensors. Well, actually, we are not sensing what people are doing. We're just using tablets at the moment. We actually, in my projects, I try to adopt what I call the John West principle. John West is a brand of canned fish in Britain. And they have the strap line that says it's the fish that John West reject that make John West the best. So I think it's very important when you do a project, you decide what you're not going to do as much as you decide what you are going to do. I'm looking down the line to see if others agree with that, but I think if you've got a small team, that's what you have to do. So we decided we weren't going to use gesture and face recognition and those sort of things at the early stages, but actually we very much believe that those things will in time evolve, but actually for us that wasn't the big thing. We wanted people to be able to go into this, a whole family of people, and use their tablet devices and interact with this thing, but it's very much an opt-in kind of technology.
All right, thanks. We have a question over on the left side.
Hi, this question is for Walt. I'm Richard Shields. I'm actually a motion picture science student at Rochester Institute of Technology. And for my senior project, I'm actually in the process of constructing an auto-stereoscopic display using lenticular optics. And I was curious if you could talk a little bit about, I guess, the audience's reaction, the consumer's reaction to acceptable viewing zones for your auto-stereoscopic displays. and if it would be necessary to position yourself relative to on axis on the display in order to view depth appropriately.
Yeah, so there's really two aspects to that question. One is portables, and the other are fixed displays. On the portable displays, the multiple viewing zones you really use for comfort rather than having multiple people watching it. For a fixed display, you want to have zones so that multiple people can watch it, but also to have the zones so that they smoothly transition from one peak zone to a next peak zone. So rather than having the sharp transitions, or the cogging, as it's been called in the past, you want to have a nice smooth transition from one zone to the other. So the design of that is critical to the success of the display.
All right, thanks. Did you have a follow-up question?
No, I'm in person.
Oh, okay. Yes. Sorry.
This is for Rob. Rob, I'm David Geffner. I'm the editor of Cinematographers Guild magazine, and our May issue actually has a piece all about IMAX, and we talked to Brian Bonnick, I think, from IMAX. And this concept of differentiation, as you said, in cinema, you know, we our readers are cinematographers and cinema lovers, and obviously they make content for the home and the cinema. And we've kind of seen content over the years, dramatic content that was traditionally reserved for the cinema drift completely over to the HBOs and cable. And cinema's becoming, you know, very much event-driven. I don't know what the percentage is, but those numbers you talked about. Do you see that trend continuing to the point where an IMAX or cinema has to become a totally immersive experience to get people to come, and the home will be essentially the repository of all these other, you know, more traditional?
Yeah, it's the right question. I mean, you know, I don't think there's any question that we're seeing the leading edge of a trend where people are. I mean, you saw some of the statistics that Sean showed. I mean, the amount of connected, driven, mobile device-driven content that television and theatrical that people are absorbing at home. I mean, it's a huge trend. You know, and the guys to my left were talking about the, you know, developments in home theater as well, and the OLED screens that you saw. I'm sure a lot of you were at CES this year. 4K. You know, things are. You know, people are experiencing television content, movie content. You know, in more places and quite frankly in better places than they were able to just 2 or 3 years ago. That would be a good thing for cinema if it prompts cinema to continue to innovate and not necessarily just be the repository of an event-driven theatrical event, but, you know, create new and different ways to get people to continue to come out and experience the cinema. I mean, there's people doing it in many different ways. You're seeing people developing 4D technology. You're seeing experimentation with high frame rate. You know, I've read about some interesting innovations in terms of second screens in movie theaters, smartphones in movie theaters, live content, alternative programming. There's a company back east called Digiplex, which is focusing almost exclusively on alternate programming within movie theaters. So to the extent innovation is being pushed by the way people are experiencing content on their mobile devices, and it bleeds into cinema, that's great for everybody. If you can go to the cinema and have a differentiated experience there, and, you know, be able to enjoy that in a different way than you enjoy watching content on your mobile devices, it's great for the consumer, and, you know, it's great for both industries.
You know, Rob, I was at a movie not too long ago. I saw a lot of those second screens during the movie. People were calling and texting each other. Not the same thing, I assume.
You know, people, they actually are experimenting. I think it works pretty well with the pre-shows in theaters. They're interactive. They want to involve you in the pre-show so people pay more attention leading up to the movie. You know, there's a very somewhat contentious, somewhat controversial debate within the cinema industry as to whether or not this next generation of moviegoers is going to need to have their second screen with them in a movie. And there's a generational divide over that. Some people think it's an inevitability. But
I would say it definitely is. Having 2 Gen Ys in my family, they go everywhere with their phones and their tablets, so they couldn't function without them. You have a question over here.
This is for Gary at Sony. Can you elaborate on how the OLED can work in adverse temperatures. Like, you know, a car, you park it up in northern Michigan, it's going to get below 32 degrees cold. It'll take some time, but if you want to watch something, what do you do there? And then the other thing is, when you leave your car out down in Florida and you don't put a thing in, you're over 100 degrees in there, and you sure don't want to wait till the air conditioner and everything if you're, you know, really into turning this thing on and seeing what you want to go see. Can you address the temperature usage of that technology, please?
It's not an extreme. I don't think you're going to see OLEDs in automobiles immediately, at least not as far as the technologies that are being used for television right now. You have to be careful. Again, it's the type of the device is sensitive to extreme temperatures, but differently than, say, LCD. If you're working in an LCD, what will happen is, say you put it out in the sun, you can burn it. It'll over temperature, it turns black, and it goes away. But say also if it has cold, what will happen is the viscosity of the crystal material it'll almost solidify. Nothing will happen, but it will recover from something like that. OLED's kind of the same way. I think what will happen is you'll run into emission efficiency issues if it starts getting too cold. If it starts getting too hot, what's going to happen is the material will overheat. It won't be able to out that extra temperature, and it'll eventually kill it. You'll drive it. Whether it's actually the OLED material or the driver materials or the system materials on the glass, I'm not sure. But if you're talking extreme, you know, you have a car parked out in Tucson and it's 120 degrees out there and 300 degrees in the car, it's not going to be very long. That may change. You're looking at some of these flexible displays, you know, the PLEDs, and there's a lot of work in that area about getting them to survive in extreme temperature. And I think that type of process probably has a lot more future for an automotive or an outdoor application instead of what you're seeing in the display technologies.
I have a question for Sean, and this is one I'm sure a lot of you have wondered about. Again, some of you may not know that Motorola's set-top box and mobility division was sold to Google. And the question I have, Sean, is what will the set-top box look like in the future? First of all, it's almost ridiculous to call it that because you can't balance one of those on an LCD TV anyway. But will there even be a need for a set-top? Can we move to a point now where we can get rid of the box? Are we at that point, or what will have to happen to make that change?
Yeah, that's a great question. I think there's always going to be a device in the home, in the living room, and wherever you're watching on the big screen, and there'll be some sort of application on most of your mobile devices. Its job so much is not going to be the ingest, you know, the physics of actually bringing the signal into a new form. But I think things like conditional access, user guides, support for all kinds of media formats, support for different kinds of video codecs, that's all going to be needed. And I think it's going to actually get more involved going forward. So there will still be something that will play that function, to take content from a provider and put it in a form where you can find it and that provider knows that that content is secure. It will probably be in the form of a media player in the home, but probably a software layer in mobile devices.
Some of you may not know there is a version of HDMI that runs on the USB physical layer, and it is called Mobile High Definition Link. It's a 5-pin mini connector, just like on your phone. And we now have televisions coming to market that are equipped with MHL inputs. And Roku, I believe about a year ago, announced a stick that plugs into that connector, and that's basically the set-top box. It hides behind the TV. It gives you a custom user overlay, a GUI, when you turn on your television to navigate through Roku, and it updates itself automatically, which apparently was something that was contentious to people that own these boxes, having to do software updates. So that would be one approach. There is really no physical box per se, but there is an external device connected through this high-density multifunction port that functions as literally a set-top box.
I just want to add one more thing. Is actually, if you go to the Motorola booth, you'll actually see us using a tablet as essentially a set-top box for HEVC coding. So we have a real-time HEVC encoder sending it to a Nexus 10 tablet, and then from the HDMI link out to the TV. And so in a sense, that's the set-top box.
That would be another approach, correct. We have a question over here.
Just a quick follow-up question for Walt. How does Dolby's autostereoscopic display solution account for backwards compatibility to 2D content rather than just viewing 3D content? As the majority of autostereoscopic displays I've seen have the incompatibility to go back to viewing just 2D content.
So you can easily do that by using switchable lenses, and some of the devices that we'll be showing in the booth have switchable lenses on it. And so that kind of leads into the obvious things that with an underlying 4K panel or a retinal panel, that it can actually do double duty as either a straight up 4K panel or as an auto stereo panel. So rather than having separate devices for those different feature sets for the broadcasters, it's one device can hit multiple feature sets.
Well, sort of follow up on that. It seems almost to me, with the limitations of auto stereo, that 4K is a gift from God, because it gives you more pixels to start with.
Correct.
And if, again, just to recap, when you do auto stereo and you define fields of view, each time you define a new one, you're dividing the resolution, the available resolution up. So it stands to reason that if you have more pixels to begin with and then you divide down, you still have more resolution per eye. So some people have said that 4K, when they see it with native 4K content, is so spectacular, they don't see the need for 3D. They say that in itself is very, very impressive. But on the other hand, you could argue that, well, 3D delivered over 4K is a big improvement over what we have today available in an auto stereo system. I mean, what's your feelings on that?
So anytime any new display technologies come out, it's always looked 3D. It was that way with NTSC. It was that way with HD. It's now, we're hearing the same thing with 4K. At the end of the day, people will get used to the enhanced contrast and colors that come out with the 4K displays. But at the end of the day, there's still other cues that bring out the 3D, and either stereoscopic or auto stereo, gives you those cues for the real 3D.
So 4K it makes it easier for you, though, when you do parallax barriers to retain more resolution.
By all means, it's all about pixel density.
Yeah.
The higher the pixel density and the much better resolution you get in the underlying images.
So, and even, we may not stop there. I mean, Sharp has shown an 8K LCD monitor that might even be better suited for auto stereo.
Absolutely. And in fact, we see the trajectory is that once the 8K panels come out, that there'll be even better auto stereo coming out along with it.
And just for those who don't want to do the math, because I know it's still early in the day, but 8K is roughly 16 times the resolution of 2K. Am I correct? So we have a question over here.
Yeah, hi. This is a question for Simon. We see a lot of these changes, like higher resolution, higher bit depth, more contrast, better colors, and all that. But in the end, you're talking about basically a technically superior image for a service or an experience that you already have. There's so many people that are in college right now, they're perfectly happy watching YouTube videos that are highly compressed. So my question is, when it comes to the new paradigm for television, TVs now are connected to your Wi-Fi box at home, and it's basically along with your iPhones and your tablets and your laptops, another screen that you have to basically access big data now on the internet. So my question is where do you see the services, like with the new paradigm of change on television, where do we start seeing new value in terms of how my life is altered on a day-to-day basis, interacting with sensory inputs and having access to big data, in terms of actually being able to see a change in my life patterns, in the way that I do business, in the way that I consume products and services, as opposed to just a better image?
Wow, that's a good question. So let's just wind that back a little bit. In terms of the demonstration or the sort of proposition we're making, we don't have tomorrow's display technology. If we had, then that would be, I'd be a millionaire, wouldn't I? So what we need to do is to be able to say, well, we're anticipating this higher resolution display technology that is available. How are people going to want to use it? And so we see this advent of a service which may well reside in the cloud, actually being able to effectively use the range of display surfaces which are available to you and to your family to allocate those images to those spaces according to your wishes. So we see that service as being something that is likely to evolve in the cloud, where that service is going to have value to you and to maybe service providers, to be able to put those images into that space, and for you to be able to interact with it using a variety of controls, including the tablets, devices, to be able to increase what we call the immersion level or your interest in those various elements. So that's what we see. It's a multi-individual collective experience. See, we spent a lot of time as in my old company, NDS, but now in Cisco, looking at what is happening with the companion device, the tablet, etc. But what we're here trying to look at is what happens in the main areas of the home. You know, one where you showed the figures, a number of people who use the living room. It was very, very high. It's a very, very important space. Let's see how television is going to evolve in that space, and to use that range of surfaces available there to express things to you in a way that's going to match your mood and your need at any given time. That's really what we're trying to do here. And we think those services are going to be eventually moving towards the cloud.
I have a question for Rob, and you talked earlier about moving to laser-based projection, and IMAX in its original form was a curved hemispheric projection system with surround sound. And as I understand it now, on the few IMAX films I've seen are just very, very large screens, but do you see a move back towards some sort of hemispheric and projection system or more immersive system? And secondly, the idea of sound. Where can we take sound in the theater so it gives the viewer an experience that they really can't get easily at home?
You know, your question with regard to the hemispheric approach. We tend to think of it more holistically. So we tend to think of the end-to-end experience with no one defining characteristic in there. So, IMAX starts with the capture of the metadata with IMAX cameras. Chris Nolan filmed The Dark Knight with IMAX cameras, and J.J. Abrams is using it now for Star Trek, and Francis Lawrence for the next Hunger Games. So an important part of the experience is to capture the image. Then you have post-production. Then you have the image quality, which you alluded to, the audio sound quality, which was your follow-up question. And then you have service, and then you have quality assurance, and then you have maintenance. So it really is end-to-end across the spectrum. And our innovations, our next generation technology relates to each facet of that distribution chain. So on the capture side, on our cameras, we're trying to make cameras easier to work with. They're big IMAX film cameras, and we're trying to make them easier, quieter, to incent more people like Brad Bird, who did Mission Impossible 4 with IMAX cameras. On the image side, we talked about laser technology. It's going to be 4K based. It's going to have blacker blacks, a greater color gamut, and it's going to brighten 90 and 100-foot screens. And to us, that's the definition of immersive. When the image quality is that level, that's where the immersiveness comes from. And on sound, on your second question, the difference between IMAX and other approaches to sound has always been that our approach is not a one-size-fits-all. It's not standardized. It's not off the shelf. Everything is customized. So the theater geometry in an IMAX theater is customized for that specific auditorium. The loudspeaker configuration, the tuning configuration, all customized for that specific auditorium. We have microphones in those auditoriums that feed back the sound to us in Toronto, so we can make sure that the experience is being maximized from a sound standpoint. And then the next generation of our laser system is going to have an upgraded audio as well. So it's all of these different facets. And something we haven't talked terribly publicly about, which is, we're now taking some of these things and we're dipping our toe gently into the home theater space. An end-to-end home theater, very high-end, ultra-high-end solution for an IMAX system at home. We've sold a few of them. We're keeping it somewhat below the radar, but to the extent that we're able to provide the same kind of holistic closed system in the home as we're able to do in the cinema, I think there's some things down the road that, excite us there.
Boy, Gary, you better get moving on that 56-inch 4K OLED. Perfect. That 56-inch 4K OLED, you better get that to market soon.
I guess we gotta get our butts in gear, don't we?
We have a question over here.
Thank you. My name is Paul Gluckman. I'm with Consumer Electronics Daily in New York. Questions for Mr. Husak and Mr. Lister. For Walt, could you describe commercially what Dolby what horse Dolby has in the glasses-free 3D TV space, and why your slides were co-branded with Philips?
Well, the Dolby 3D is really just a trade name. It's a partnership with Philips and Dolby, and plus we actually have some other partners that if you go by the booth you'll see. The intent is to commercialize the display technology through the normal channels that we would commercialize things through, but also to sort of build an ecosystem where we can deliver the content and also the experience all the way to the home. So it's a typical scenario where, similar to what we do with our audio technologies, now we're applying it to video technologies, again, through a partnership.
For Mr. Lister, in your role as board member of 3Net, Display Search has estimated that shipments in 2012 of TVs with the embedded 3D feature rose significantly over 2011. To what extent can you say that 3Net activations have kept pace with those shipment increases?
You know, it's a challenge. It's a challenging industry so far, and Walt's talking about some of the auto stereoscopic developments that are coming out. I think that's very important. So far, 3Net was ambitious. They decided it wouldn't be a video on demand kind of ecosystem. It would be a linear 24/7 channel, originally programmed. And as I said in my original comments, you can't fault people for being innovative and aggressive. The business model has been very challenging. So what they've done successfully is they've been able to license a lot of this content that would otherwise not have been watched by a tremendous amount of people, since I think they're only carried by DirecTV right now as a major carrier, and license that to consumer electronics companies and other displays around the world. I do think, to the extent that we see some successful innovations of next generation 3D, particularly in auto stereo, investments like 3Net will ultimately pay off, but so far it's been a challenge.
I believe 3Net has also announced publicly that they've started native 4K content production. Can you comment on that?
Yeah, that's correct. Tom Cosgrove talked about that a little bit at CES, and for IMAX, speaking from IMAX's perspective, 4K, and what Sony has done in the cinema industry of 4K has always been, impressive and interesting. Our emphasis has always been on contrast, and for a while there were some sacrifices that had to be made, in 4K and contrast. But we think that the next generation is going to take care of that. We use 2K, side-by-side 2K systems, and an image enhancement tool that overlays the pixels, so you get a 4K image and you're still able to get contrast. But for next generation 4K, things that 3Net are looking into doing, some of what Walt talked about, that auto stereo is enabled by next generation 4K. We think it's a terrific technology.
Thank you very much.
I have a question for Sean. One of the things that always seems to happen with MPEG compression standards is as soon as everybody adopts it, a new one comes along, but there's a large installed base of products out there that support the older standard. And that's certainly the case with MPEG 2 and broadcast television. So to move to the high-efficiency video codec, H.265, what challenges does that present to a television manufacturer that wants to take advantage of it?
Yeah, something really interesting about HEVC, which is this new compression standard, is it's being developed very rapidly. And as I mentioned, we have a real-time HEVC encoder at the booth. But interestingly, we have tablets running HEVC decoders right now. So I think what's going to happen here is that HEVC is not going to compete against AVC right away in the home, delivery to the home over DirecTV or something, because you still need some hardware changes out and you need to overlay. But I think we're going to see adaptive bitrate delivery to smart TVs and tablets and smartphones right away. So the adoption will start happening with HEVC, and then over time we will build in the overlay. And then part of the business, of course, of Motorola and other companies in this space is to provide the service providers and the distributors with equipment to transcode from MPEG 2 to AVC or AVC to MPEG 2. And so you can imagine that we'll be delivering those kinds of things for transcoding. So we can deliver over a satellite in HEVC and get the bandwidth efficiencies, but then transcode to AVC to delivery to the home. And over time, we'll pick it up. So
if I bought a television last year, a loaded smart TV which supports AVC, but I want to take advantage of HEVC encoded content, I'm going to still need the quote-unquote set-top box.
You're going to need some kind of, format converter, set-top box or tablet or something.
We have a question over here. Oh, I'm sorry, on this side. No, but that's okay. We haven't come over to the side very often.
Okay, hi. Yeah, this question is for Gary. Can 4K OLED TV screens and 3D TV technologies could be or are being currently integrated?
Yeah, that should be no problem. There are a number of ways you could do that, similar ways as you do with, say, LCD, either both with active glass or a passive glass system. Kind of the nice thing is that OLED switching speed is very, very fast, much faster than LCD. So I think that the actual 3D quality coming off an OLED should be much better than what you're seeing now. But it's very easy to do.
Okay, thank you. Just don't take 40 years for that.
Yeah, we'll be a little faster.
And we have a question over here.
Okay, this is for the whole panel. Lucas in Star Wars, the first time with R2-D2, has a holographic projection, which is 3D. When do we get the opportunity to have that at the home and is the experience without having a television or a screen?
Well, if you were here, I think it was 2 years ago, it was NTT, I believe, that showed an actual hologram. It was not the easiest thing to see. It was very, very small. It kind of looked like a long lens magnifier to see it, but they did create a hologram that was a little cube that could rotate. That obviously takes a lot of computational power. And again, is that a projected image? Is it a virtual self-contained image? I'd like to throw that to the panel and see if they have any crystal ball predictions on whether we're close to that or that's still something that's a long ways off. Anybody want to take a stab at it?
I think there was I'll just go first. I think there was a display in Las Vegas last year of a kind of a holographic Kanye West concert that was really well received. They took they took images of him that had been used previously, and then post-mortem were able to create.
That was Tupac Shakur, right?
Oh, you're right. Sorry, that was Tupac Shakur. That's right. Kanye West is very much alive. And I think the company that did that was talking about doing the same thing with Elvis Presley and Frank Sinatra. They were going to try and negotiate some rights to do that. From what I wasn't there. From what I understand, it was people thought it was a very enjoyable and convincing experience.
I don't know if it was a true hologram, but it was certainly something that appeared to be projected in thin air, which is a trick that can be done with steam, water, other media that reflects enough light. That
I don't think there was much proprietary technology from what I read about there.
No, I don't think there was either. But yeah, as far as a true hologram, I do think that's a long ways off yet. Anyone else want to take a stab at it, or no? Well, maybe Western Union wants to get into that. They can have Western Union holograms. A virtual person shows up at your house to read you a message. Okay. I actually have one last question for Simon, and that's kind of the same question that I phrased for Robert, which is, in this new experience in home, have you looked into doing something that's more of a hemispheric or a curved projection as opposed to a flat projection? Or not projection, you corrected me earlier, but a curved image as opposed to a flat image, and maybe one that even warps around you and above you a little bit.
Yeah, that's a very good question. We actually believe in tileable technology because we don't actually believe that the world of the future will be 16 by 9. We think that, as I say, any image will be shown in its correct size and shape. Therefore, what you really want to do is create technology that fills the space you've got. And if that's a flat wall, it's a flat wall. If it's a curved wall, it's a curved wall. And we want to actually see that technology applied to that space to fill it. And the question is how to do that. Well, obviously, we'd like to see the rollable OLED technology, please, as soon as possible. But also, we have a belief that that actually tiles themselves actually provide a very good solution. I mentioned about I have a next-door neighbour who spent £85,000. I worked that out in dollars. It's getting a bigger figure all the time. Sorry, a smaller figure all the time. But £85,000 putting a 105-inch screen in his house, and he had to have a crane to lift it in. So if the future of large-screen TV is that, then we need to invest in the crane industry. And what I'd like to be able to see is small panels that you can actually just put, just like tiling your bathroom, and create the space. And you could do that on a curved surface, absolutely.
Very good. Yes, tiled is an interesting concept, and assuming that you can make the edges seamless, then it's almost like Legos.
That's absolutely right. Now, we want to ask a question about the size of bezels, because getting the bezel width down is a critical thing. And I understand that for OLED, it can actually be virtually zero. Is that correct?
Some OLEDs can. there are two constructions right now of doing OLED. One of them is called top emission, the other is bottom emission. With bottom emission, you're actually shooting light through the driver area. And where that gets into an issue is that driver area now is in an optical part of the screen on the outside. So to make that seamless is going to be hard, although Samsung in particular has done a very good job of hiding that on their latest panels. Top emission is a technology that we're using wherein the entire emission comes off the opposite direction. And that's actually very easy to do, where you can put the whole thing behind it.
So I think that's a very exciting proposition, actually, to see small panels that you can put together with virtually zero bezel, and you can fill the space that you've got.
And preferably with a self-stick adhesive on the back, so you can just kind of put them into place. And when the TV wears out, you just peel it off and throw it away.
No, seriously, I think it's going to come.
There we go, 8K disposable television.
I'm really looking forward to it. I think this is going to be a very exciting future.
Yes. We've actually reached the end of our time. I'd like to thank all of our panelists, Gary Mandle, Robert Lister, Walt Husak, Sean McCarthy, and Simon Parnall, for giving us a very interesting look into some really way out there applications, the whole ecosystems of displays. And there's a lot of things we haven't touched on yet, but I urge you all to look around the show. You will see a lot of these products here. You'll see a lot of 4K displays. You will see OLEDs. Simon's group has their system on display. And you're welcome to ask questions of any of the panelists as long as they're willing to stay here after our session ends. But thank you all for coming, and enjoy the rest of your show.